Good evening and welcome to our presentation about the self-driving Uber car that led to death in 2018. On March 18, 2018, a self-driving Uber, Volvo SUV to be exact, hit and killed Elaine Herzberg, who was a pedestrian crossing the road with a bicycle. The National Traffic Safety Board released a document that claimed it was due to the inability of the car to recognize any object as a pedestrian when it was not near a crosswalk. At the time, Uber had disabled the emergency braking system, trusting that the driver would stop if faced with such a situation. However, the system was not designed to alert the operator, who intervened much too late, having been distracted while streaming the show The Voice. Uber assured the National Traffic Safety Board that it has since modified programming to include jaywalkers amongst its recognized objects. Arizona also suspended Uber's ability to test self-driving cars on the road. But this does not cover the depths of the issues that were brought up by this incident. But before we go any deeper into the aforementioned issues, let us first have a look at what an autonomous vehicle implies and what degrees of autonomous driving actually exist. There are 6 levels of vehicle autonomy ranging from 0 to 5. First, we have level 0. Most cars fall under this category. The driver is in charge of all the actual real-time functions and operations of the car, although there are certain necessary essential driving functions in place, such as braking. Second, we have level 1. In this case, although the driver is still in charge of majority of the real-time functions of the car, there are certain extra features such as lane assist and adaptive cruise control that have been added to aid the driver. Next, we have level 2. This category can still be classified as partial automation. The drivers still need to be in charge and pay attention to the road. However, the car has the capability to brake and accelerate on its own. Moving on to level 3, also referred to as conditional automation. Here, the vehicles have a sense of environmental detection, which means that they can make informed decisions on their own. This may, for example, include the decision to drive past a slow-moving vehicle. However, a human override is still necessary in the case that vehicle is incapable of executing a task. But overall, level 3 vehicles should be able to drive themselves over long motor roads. Now for level 4. At level 4, the car is capable of steering, braking, accelerating, decelerating, monitoring the vehicles and external environment, as well as responding to events in real time and determining when to change lanes, turn, and use signals. The vehicle informs the driver when conditions are safe to turn on to the autonomous mode, but it cannot predict traffic jams or speed up on the highway. Finally, we come to level 5. At this level, the vehicle has complete autonomy and no longer requires any human interference. In addition to the features of a level 4 vehicle, a level 5 vehicle can automatically predict traffic jams. Only selected few car companies like Tesla have been able to successfully test level 5 cars. BMW, Ford, and Honda are expected to develop fully autonomous cars by 2021. Going ahead in the presentation, we will mainly be focusing on levels 3, 4, and 5. But before we proceed further into the presentation, let's first have a look at a few questions that could be raised through this case. From Iyad Rahwan's remarkable outlook on the situation considering autonomous vehicles, he claimed that over 90% of car accidents can be prevented through the mass use of autonomous vehicles, as it removes the question of human error. Numerically, this means that 1.08 million people could be saved from such disasters every year. Although this seems appealing at a first glance, it raises a number of other ethical questions and issues. Under normal circumstances, we could conclude certain accidents to be blamed upon human instinct, but designing an algorithm for vehicles to react in the same way may seem unethical in certain viewpoints. Therefore, we must come to a conclusion that both appeals to the customer, in this case mass society, and also appeals to an ethical outlook. Additionally, autonomous cars may replace the jobs of numerous Uber and taxi drivers worldwide. Although this could reduce the overall death rate,
The Uber case can reflect two major ethical issues: ethics about decision and liability. In a hypothetical situation, if the car must decide whether it crashes towards a group of people on the road, or shifts the direction but hits an innocent person on the sideway, what should they do? Currently, value functions are used by engineers in their design algorithms. By the IEEE Code of Ethics, the design algorithm has to hold the paramount safety of public. A self-driving car is designed to face the whole society, which means that every single person, no matter driver or passerby, is affected by it. According to the consequentialism, which means that whether an act is morally right depends only on the consequences. In our hypothetical case, if the consequences are causing 5 people and 1 person to die respectively, then by the Code of Ethics, we have to choose the second one. In further research, our group finds that, in the actual design, the algorithm is intended to maximize the function's value and thus minimize casualties in return, which is the same as the consequentialism analysis we have. Triggered by the Uber self-driving car incident, the ethical issue raises in the liability in a collision involving self-driving cars. Who is at fault? The manufacturing company, the unlawful pedestrian, the safety driver, or someone else? In this case, Uber Corporation wasn't charged with any guilt, yet the safety driver was charged with neglect and homicide. But does it mean the design company can always free of charge, especially when the Uber design wasn't flawless, as it took away the ability to brake itself when emergency happens? When charging people for guilt, it usually charges the one who conducts human error in a car accident. But how to define human error when it comes to the design algorithm in self-driving cars? For example, issued by British government, the Automated and Electric Vehicle Act 2018 only regulates 2 circumstances where the software could be excluded from the charge. Nevertheless, how and when to charge the car is still in the gray area. Additionally, more people or groups, such as the manufacturing company, the producer, the programmer, may be responsible for accidents involving self-driving vehicles, and thus leads to more complex scenarios than normal case. Hence, the standard of judgment of conviction is hard to set. On one hand, the lawmaker can sentence the person who is responsible for the algorithm flaw. On the other hand, as the algorithm is a group work, it is impossible to blame a specific person. Yet, free of charge seems an unfair treatment to the person who suffers damages in a car accident. Hence, it is still debatable about the liability regarding to this area. But our group thinks that in order to fully solve the ethical issue in this aspect, more concrete laws and industry standards are needed to be implemented by the government and industry in the near future. Aside from the Uber case, other concerns still exist. For example, if the car is in a position which either the passengers in the car has to die or the innocent pedestrians on the outside, then whom to sacrifice? On one hand, people believe that design ought to minimize casualty, especially when innocent people are involved. However, on the other hand, customers may not willing to purchase such car. Even a step further, when the technology is advanced enough to identify the identity of people, during extreme circumstances, should they sacrifice certain group in order to save another? However, even over 2.3 million people, spanning over 233 countries, took the Moral Machine Questionnaire, which aimed to solve this problem. There isn't one absolute agreement.
Hi, I'm Flora. I'm going to briefly talk about what we will do differently based on the Uber case. As we know, there are actually 2 main reasons causing this unfortunate case. Firstly, according to the news, Uber's self-driving system initially classified the pedestrian as an unknown object, then as a vehicle, then as a bicycle. Secondly, the Uber taxi driver was watching television when the accident happened. So our group came up with few solutions corresponding to two different aspects. One is ethical solution, another one is technology improvement. So firstly is the ethical solution. We saw the decision-making problems were existed in the Uber self-driving system. So based on the ethical analysis above, we discussed about to apply consequentialism into autonomous driving system. On the other hand, more standardized regulations and laws needs to be established and implemented by the near future. Okay, so as for the technical problem, what I want to introduce is Cooperative Vehicle Infrastructure System, also called CVIS. It can largely improve overall visibility, which can solve the problem that traditional self-driving cars do not have strong perception. Also, CVIS provide interaction between vehicle to vehicle and also vehicle to infrastructure, so the car may can notice pedestrian in advance and correspondingly adjust the path at that time. So, what is it? Just let me give you a simple example. Let's think about some A-star students at school. They got really high academic achievement, but they are completely not good at social and communication. So what these kind of students graduate and enter the society? What happened? They may face lots of problems, right? So we consider those independent self-driving car as those A-star students. They may have really high precision on classification, and maybe they can make correct decision on traffic scene in the lab environment. But if we put them into our complicated traffic system in our real world, do you think this smart car can still do a good job? What CVIS aims to do is to change the mode from independent intelligence to hybrid one. More specifically, the intelligence system tends to construct a standard network system, which would enhance vehicle to vehicle and also vehicle to infrastructure communication. There are 5 main elements to achieve this. Firstly, of course, we need to have autonomous vehicle, but what's different is that these vehicles are able to communicate and also cooperate. And then the second one is roadside infrastructure, like cameras and radar installed on the road for perception and interaction. In short, to make roads become intelligent. Also, we need to get some personal devices, central services, and network. More specifically, how does this system work? Obviously, the vehicle infrastructure cooperative system provides strong interactive capabilities. It can acquire real-time vehicles and road information, allowing interaction and sharing. Not only guesses what the car is going to do, but also perceives the situation out of sight in advance accurately and then to make better decisions. It can also largely improve perception, since more vision, radar, and other sensors can be mounted on the cars and street light poles. The simultaneous perception of cars and road terminals can minimize blind zones and support safer traffic. So finally, we get to here. So our group firmly believes the self-driving car industry should keep developing, not just limited to the independent self-driving cars, but also extend to a complete intelligent transport system. What it can bring to us not only enabling safer road traffic, but also let human beings live lives in a much more efficient way. But before we reach that levels, there are still many important things need to be considered and problems need to be solved. First thing is ethics. As we have discussed above, although some of them can be figured out through the ethical frameworks, but there are still lots of ethical concerns need to be kept considering and discussing by the public. And then is lots of technical challenges and difficulties left for scientists. Then is as for the law system, more concrete laws are needed to be completed and implemented by the government. The infrastructure also needs to be planned accordingly. Lastly, the relevant industries, such as the car insurance industry, need to make corresponding changes for adapting this revolution in the near future. So yeah, that's all. After we get full preparation, maybe that day will come sooner than we think. So thanks for listening.